hopefully one of the themes you're getting from all this is we're trying to provide multiple entry points for automation. It's not a single thing. And we have the very, roll up your sleeves, writing service code. We have looking at tooling with net DevOps. And then we have just looking at operations, right? Not everyone, gasp, wants to write code. Some people just want to use tools to get stuff done. And that's really what the operations track is about. From a portfolio perspective, this is what CNC is about. We're going to talk a little bit about CNC, and it's really about, for operations folks, using all the tools, using NSO on the inside, and some pre-built stuff to really focus on building services, running networks, and those kinds of things. So with that, I'm going to hand things over to Vishakha, who's going to take us through CNC.
Hi, everyone. Hello. OK. So the reason I chose this music because it's representative of a very stupid thing I did, and I thought it was a great icebreaker to tell you about that stupid thing, so you trust me with my presentation. When I was in 4th grade, I took a pencil, or I don't remember, or blade or something, and I drew the Harry Potter scar on my forehead. Which is why you can see it on a good day. You can't see it today, which is why I thought I would choose this. So my name is Vishakha, Mysore. I'm going to talk about Crosswork Network Controller. A small introduction for people who don't know it, a recap for people who already do, and then we have a 5.0 update, which is exciting because I think 5.0 was just released a couple of days ago, and the images are going to be up in a couple more days. OK. All right, so for the agenda, I want to talk about what's in it for you. Why should you care about this specific event or this specific session? I'm going to talk about CNC basics. I may run through this a little quickly because I only have 19 minutes, and I don't want to eat into your lunch. I want to eat lunch, but not into yours. And then I'm going to talk about new in CNC 5.0. And then we have a roadmap session for which I want your inputs. That's on the 11th of May, and we can follow up there. OK, so what's in it for me? There's a lot of speakers here today about orchestration and automation, and I think we've heard straight from the horse's mouth about a lot of market trends influencing this move to automation. I want to talk a little bit about the numbers behind this and set the stage for an overview of Crosswork Network Controller and how it adds value to your network. OK, so we know this. We know the Internet of the future is changing, mostly because we, as a society, are changing. We're changing the way we live, the way we work, the way we play. And this is all impacting service providers. This is all impacting the load on networks today. We also have new participants coming in, and that's not just Gen Z. It's also a lot of IoT devices being connected into the network. But what this really means is that there's a lot of new potential revenue streams that service providers want to go after, and that's where we want to come in and help them do that. So just for reference, this slide only goes up to 2022, but it just talks a little bit about the trends of what we're seeing. So a dollar in CapEx in 2022 has to do 11 times more work than it did in 2012. Usually with people, that goes back. We do less work as we age. But for CapEx, that's the opposite. So in 2023, it's going to get worse. Going forward, it's going to get worse, which means there's a lot of margin squeeze for enterprises, for service providers. But then there's a great opportunity for people like Cisco to come in with modernized automation, with software-defined networking, and with mass-scale infrastructures, all of which we're going to talk about today with CNC. OK, so modernized operations, I think many of you know this. We want to talk a little bit about what happens in day -1, day 0, and day 1. And I know most of you know this. I just want to set the stage for this because we're going to talk about CNC use cases in each one of these segments. Now, let's get into the Crosswork Network Controller, right? Before we talk about exactly what CNC is, I think we have to talk a little bit about the portfolio itself. So we have, I think everyone's familiar, we have WAN Automation Engine, which is WAY. We have EPNM, which is your device lifecycle management. And of course, we have the star of the show. We have NSO. And I'm going to talk about how NSO comes into Crosswork Network Controller and how there's like this perfect marriage between the two when we're talking about CNC. So I want to bring your attention to 3 things. One is the Crosswork Hierarchical Controller. The second is the Crosswork Network Controller. The third is the Optical Controller. So your hierarchical controller kind of bridges your multi-domain, multi-layer IP and optical. Your SDN controller, which is CNC, does the IP part, and your ONC does the optical part. So Moti and I know Daniel, both of them have sessions on HCO, so please check that out. This session is about CNC. And then we also have Crosswork Cloud, which is trust insights, network insights, and traffic analysis. I'm not going to touch upon those too much, but if you're interested, it's on the Crosswork Cloud website, or you can find one of us and we can talk to you about it a little bit. So this is where CNC sits in our portfolio, right? There's an invisible line now connecting CNC with NSO, and we're going to talk about that, and we're going to talk about how NSO really brings in the orchestration part of Crosswork automation portfolio. So what do we aim to do with CNC specifically? We've seen many challenges. We start with cumbersome service provisioning. There was a data point earlier today from the Croatia telecom team that talks about how service provisioning took days, if not more. We're going to talk about how that reduces to hours. We also know that there's a lot of bandwidth swings, overcapacity, congestion. All of this leads to bad user experience, or at least unhealthy user experience that service providers want to very much avoid. We're also going to talk a little bit about maintaining SLAs and how NSO comes in and helps with that. The last thing I'm going to talk about, and this was a theme in a lot of the presentations today, which is siloed tools, fragmented visibility, and the visibility is in itself fragmented, so that's a little meta, so that's fun there. So siloed tools, fragmented visibility, and we're going to talk about how CNC comes in and does that integrated service lifecycle management under the same UI, under the same pane of glass. Okay, so before we get in, again, a lot of stuff before we get in. I want to talk about the core principles for CNC. There's 3 core principles. The first one is visibility, and I think this is one of the things that is very much underrated within what CNC does. We firmly believe if you cannot see, or if you cannot fully visualize, or if you do not have 100% visibility into your network, everything else kind of just falls apart. You cannot manage your network. You cannot optimize your network. You cannot orchestrate your network if you don't know what's happening in there. So we bring in a lot of capabilities around audit, around topology, around discovery. And a lot of this is automatic, real-time, and in a closed-loop fashion, which is very exciting. I'm going to talk about that next. We also bring in a lot of insights. So you see what's happening in your network. You know what's happening in your network. Why is it happening? How can I change my network to prevent this? NSO, can you help? So NSO comes in with the action part, but for the insights part, we tell you what's happening with your network health, your service health, with your traffic analysis, with correlation of your alarms and all of that stuff. So now you know what's happening in your network, why it's happening, and we also provide, in a lot of situations, recommendations on how to fix that. And the recommendations and the actions are carried out by, of course, NSO. So NSO comes in and says, I'm going to do everything you need. Just tell me what you need, and I'm going to do it. And we're going to talk about all 3 of these in each use case that we go through next. OK, so let's get into it, the basics. So first off, starting with visualization, which is one of the things that we spoke about, which is one of the core principles of CNC. We have real-time visibility into topology, into traffic, interfaces, devices, deep inventory, all of that stuff in CNC from the get-go. So you switch CNC on, there's a PCE underneath, and you have all of this visualization. You can go into any of these details. You can see what's happening. You can see the health. You can see path changes. You can see state changes, all of that stuff. I want to bring your attention to this. The protocols we support are RSVP, SR, SRv6, and TreeSID. Because this is a very TE-heavy product, we're also going to talk a little bit about Flex-Algos later. But one of the things that we do is kind of bring in the traffic engineering element from these algorithms and kind of run with it. It's kind of on steroids with CNC, and we'll talk a little bit about that also. So the solution to the challenge of not being able to 100% see your network, or 100% see all the details in your network and under a single pane of glass, the solution is to have real-time automated discovery of the network via BGPLS. We discover it via BGPLS. We build this really cool UI. And it's not just the UI. You have this in your API as well, and then you have all of the information when you drill down deeper and deeper. What this comes with, though, and we have a separate slide for this, is it comes with real-time automatic detection of your topology changes, and that kind of goes into your self-healing and your closed-loop automation use cases. So the outcome here is you have automatic topology discovery, real-time information, and all the stuff that we talked about. Again, I'm running through this because there's not a lot of time, but if you want to learn more, a lot of the Crosswork folks are here, so reach out to us and we'll go through this in detail if you want. Okay. The second one, and this is where NSO kind of really shines, is service and transport provisioning. We know even from today's presentations that service provisioning, transport provisioning is cumbersome, it's time-consuming, it's error-prone, there could be a lot of changes, there could be a lot of errors, and in most cases, if you have traffic engineer transports underneath, there's a missing context linkage between service and transport, which leads to you not actually being able to see what's happening in your network, or you not being able to see the health of everything that's affecting your service in the network. And I'm going to talk about service health also in just a minute. But the solution to this in 3 letters is actually just NSO. So behind the scenes, we have CNC talking to NSO and saying, hey, go provision this service, go provision this model, do this service to transport binding. And then the loop closes where NSO provisions it. And then we visualize all of the details and all of the information on CNC. And you actually don't have to go outside the CNC workflow at all to provision this via NSO also. So it's kind of under the hood for customers actually doing this. It's a single pane of glass. The outcome, of course, is rapid time to value. Your provisioning workflow is reduced from days to weeks, days and weeks to minutes with service and transport provisioning with CNC and NSO. Some of the objectives we support are latency, IGP-TE, and I'll talk about this here in the next slide. So remember in the first visualization slide, I talked about automatic topology changes, automatic detection of topology changes. Let's take an example. So let's say you have a service with low latency provision in the network, and it's like an ultra-low latency service, and something happens along the path of that service that makes it no longer the lowest latency path you could have in the network. So typically, you would go in and you would say, hey, let me find another path, provision it, change it, and all of that. Again, takes a lot of time. Here, what happens is the network itself, or CNC itself, understands that there has been a change. There has been a network event that violates an intent that has already been defined in the network. The intent here is latency. And it goes ahead and computes a path, a new path, which does not violate the intent, and provisions it automatically. And NSO has a copy of this. CNC has a copy of this. We see everything on the UI, and we have historical information on why this happened, when this happened, what the old path was, what the new path was, and then coming back full circle to that visibility, insights, and action. So the metrics we support are latency, IGP-TE, metric minimization. We also support Flex-Algo, so you can kind of customize the metrics that you want to do. For constraints, we support affinities, disjoint constraints, and bandwidth. I'm going to talk about bandwidth next. So this actually is my favorite use case. It's called local congestion mitigation, and it is a bandwidth optimization use case. The best way to understand this is to say, understand this in terms of how humans deal with traffic. So if you wanted to go from Stockholm to Copenhagen, you would not, and there's a lot of traffic, you would not want Google to tell you to go from Stockholm to London, London to Copenhagen, just because there's no traffic between these 2 lines. You would want Google to say, hey, take these alternate routes. Maybe they're smaller roads, maybe they're not a highway, maybe they go through obscure towns, but you would want to get to your destination without so much of a detour. And that's exactly what LCM does. So LCM sees all of the traffic that's going through all of these interfaces. You can set the thresholds you want for your interfaces and say, let's say there's an interface that's above, that has utilization above a threshold that you've set. So LCM is going to say, hey, just reroute it in and around this interface. Don't detour it too much, so that your goal class of traffic or your high priority traffic is always on the shortest path, but your best effort, your IGP traffic, anything that's up for optimization, is on not the most optimal paths, but not the most detoured paths either. So this is what local congestion mitigation does. What happens here, and I want to clarify this. What happens here with the outcome is not that you can always use every bit of capacity you have in your network. What happens here is that you don't have to over-provision your network for traffic spikes. You can do better planning, of course, but you don't have to provision an extra 100 gig interface just because you think there's going to be a traffic spike for 6 hours in a day. LCM can do that for you. It can handle all of these spikes. But of course, if you've not done capacity planning properly, that's a different issue. So that's what LCM does. Of course, it is. The outcome here is you have better service SLAs. You don't have bandwidth swings. End user experience is better, so you have minimized impact to service levels. Excellent stuff all around. And we have we have a white paper on this actually on the Cisco.com website if you want to check it out. OK, so the next one, actually my second favorite use case, enhanced traffic engineering with Flex-Algo. So the challenge here is really the inability to scale end-to-end if you want super fine-grained control over your services or over your network. The solution is to customize your IGP shortest path computation. And when I say customize, it's to actually make the computation make sense for your network metrics, and not for someone else's definition of what should make sense for your network. So you can establish traffic engineered paths from anywhere to anywhere, and it's automatically computed by the IGP. What CNC does is it shows you which algorithms, which links and which nodes are part of the Flex-Algo definition. It also shows you what the definition actually is. And added bonus point, with NSO, you can actually configure the definitions using a template on your network, and that's automatically detected by CNC. So you have enhanced control, you have operational flexibility, and you can actually custom fit any of your 5G slices for the applications that you're looking to implement. So this is enhanced traffic engineering with Flex-Algo. This is one of the things that's heating up, especially in tandem with SRv6, which relies heavily on Flex-Algo definitions. OK, so taking a step out of unicast for just one tiny moment, we want to step into multicast. And I want to talk about TreeSID, which is SR's multicast protocol. And I want to talk about TreeSID visualization. This is super special to CNC because this is the first time a controller solution has had real-time visibility of a multicast network, of multicast trees, of all the information from the source to the leaf to the replication points to bud nodes and all of that. So the challenge is, again, very similar to what we've seen in unicast. But in multicast, the challenge is aggravated mostly because of how complicated multicast is as a protocol or as a set of protocols. So we've seen a lot of customers, especially on the broadcast side, really, really like this because they've never seen this, and it makes understanding their trees and visualizing their trees so easy, especially if you have disjoint trees and if you have disjointness as a constraint. So the outcome here is faster time to value. It's an automation-friendly, controller-friendly protocol. TreeSID is very good that way. What this allows us to do is build on top of visualization for optimization, for bandwidth use cases, and I'll talk about that in what's new in 5.0. So the last one I'm going to talk about is service health monitoring. So of course, when you deploy a service, you want to make sure that the service is healthy, the underlying components are healthy. But if you do that manually, like I was talking about, there's a lot of times there's missing context between the service, the transport, the interface, and all the way down to the device, the line card, and all of that. So the solution is to have, with CNC, end-to-end service monitoring. So it monitors the health of your service, and it monitors all the components that affect the health of your service. So that's the linkage between service and underlying components. We have proactive causality models that talk about or that try to detect what's actually happening with the health. And the outcome is a reduction in time to detect and improved user experience and operator productivity. So if you're interested in this, I know Paula has a session during the next couple of days. I believe it's tomorrow, and I know Farouk also has a session on this. So please check them out if you're interested. We have actually a lot of amazing things happening on this in those sessions. OK, so what's new in 5.0? A lot of things are new in 5.0. So I'm going to talk about A few things that are new in 5.0 in detail. I'm going to touch upon a few things that we're not going to go into completely in this session, but if you're interested, again, reach out to us. So I want to talk a little bit about alignment to IETF, L2NM and L3NM models. That's something that's new in 5.0, again, through NSO's provisioning use cases. I also want to talk about Circuit Style Manager, which is a bandwidth reservation and bandwidth guarantee system with path protection. That's super interesting. I'm going to talk about that in detail. We also have SR3 SID provisioning. Again, NSO comes into the picture for MVPN provisioning and dynamic path calculation, and we'll talk about that. We have deployment on AWS and EC2. I know Ravi has a session on that, I think later today. So if you're interested, please check it out. We also have air-gapped licensing for CNC. Again, kind of housekeeping stuff because we have a couple of government customers that want that. We have GNMI support for optimization. There were a lot of multi-vendor data points today. And of course, that's the nature of the game. We're all multi-vendor. We all try to be as standard as possible. And we all want to make sure that optimization and CNC works for every vendor in the network. As to secure ZTP, we have new secure ZTP. We have deep inventory and event dashboards. I'm going to talk about those two in detail. We also have SRv6 extension for service health monitoring, which is new in 5.0. So the FCS is this month, I believe in the next couple of days, if I'm not wrong. So look out for that. There's a lot of cool stuff happening on 5.0. OK, so first I want to go into circuit style provisioning and visualization, because this is actually really super cool. So you have a class of services where it's super gold class, it's super high privilege services, and you want to deliver a bandwidth guaranteed section of your network with path protection over segment routing. So you have this is assuming you have segment routing in your network, and you don't want to change anything in order to get those bandwidth guaranteed services. So what this does is it actually leverages segment routing infrastructure to carry any kind of service. It could be OTN or TDM type services. It could be CEM. And we're going to talk about exactly how this works. So the solution is to pre-book some bandwidth in the network. So CNC books bandwidth in the network in a forward path and a reverse path. That's kind of the circuit behavior that we're talking about. And it also calculates the path that has the most bandwidth to spare. It calculates the path that has the bandwidth that you need for the guarantee. Not only that, it actually calculates the restore protected path, which is kind of your second preference candidate path, just in case something happens to your primary path or your working path. In addition to that, should something happen to the secondary path as well, there is a restore path calculator. So there's all of these failovers and all of these fail-safes to make sure that that guaranteed bandwidth path never goes down. Or even if it does, there's always an option 2 and an option 3, which is just good planning, if you ask me. So the outcome is you can use your segment routing infrastructure to carry any kinds of services, including your most demanding ones. And this is kind of how it works. You have your working LSP, which is in blue. It's bidirectional, so it's forward and reverse, A to Z, Z to A. You have your protect LSP, which is also calculated and provisioned. So there's a bandwidth guarantee on both of these when you ask CNC to find a path and provision it. So if the working goes down, it fails over to protect LSP within 50 milliseconds. If the protect LSP goes down, CNC calculates the restore and fails over pretty quickly to that as well. So this is what guaranteed bandwidth services do. It's called circuit style, and if you're interested, please reach out to us once again for a deep dive. And that's new in 5.0. So tree-sit provisioning, again, very complicated. Very similar problem to unicast provisioning, but much more aggravated, much more problematic, and much more complex. So what CNC does is it leverages actually NSO to provision the MVPN paths, and it leverages PCE to calculate and dynamically update your paths. So again, You don't really have to calculate the path yourself. You don't really have to make sure that the intent provision, in this case, it could be latency, it could be whatever. The intent provision in your network, if it changes, you don't have to make sure that there's someone sitting there and changing the paths. CNC is going to do that for you, NSO is going to do that for you. And of course, it comes full circle. Once you provision, you can visualize, you can see what's happening. You can look into pad details, you can look into leaf details, root details, all of that good stuff, of course, via GUI and via API. Again, this is faster time to value, and this is much more important with multicast because, again, very complex. It reduces provisioning time from to minutes from days, from hours, if not days. And of course, there's provisioning accuracy. One thing we've seen, which is a constant theme across multicast, is that it's there's a lot of scope for human error. And with NSO and with CNC, that provisioning accuracy kind of shoots up, and error, it's not error prone at all. OK, so device management and deep inventory, this is kind of a niche use case where you want to understand exactly, at a low level, at an inventory level, kind of identify the association between your interface, your pluggable, your port, your line card, in order to rapidly do analysis and rapidly troubleshoot tasks. So what CNC does is it gives you a complete device and interface inventory. It gives you deep details on what's happening with the inventory of each device, provides a filterable view of where the operator can identify what's happening in the network, what's happening with each of these components. And you can see that right there with the inventory and everything that's listed under it. So you can see the status. You can go in, you can click in. And this kind of reduces the time to remediation. And you can also see what recommendations or what you need to do in order to fix these things. Event dashboard is, again, another subset of device management. There's a lot of alarms, a lot of events that are generated by either the controller, either your network elements, and you want to make sure you're looking at the right things. You want to make sure you're not confusing these alarms, and you want to make sure that it's easy to look into your most severe alarms and expedite troubleshooting. So what we do with CNC, new in CNC 5.0 again, is to align alarms and events to a single format. And we also enable drill down into the specific tasks to complete all of these troubleshooting all of these alarms and stuff. So it expedites your mean time to remediation. You're not wasting time looking at things that are not relevant. And CNC gives you kind of the head start to figure out what actually is relevant and go from there. OK, I think this is the last one I'm going to talk about, CNC on AWS. So CNC so far has been pretty on-prem, pretty heavy. One of the things that we've heard over and over again is a quicker time to value. So a lot of customers want to set up or tear down CNC in a matter of minutes, even if it is just for POC purposes. One of the things you can do with CNC on AWS is kind of bypass a lot of the certification, take advantage of the platform resiliency that comes with AWS, take advantage of the huge community of expertise that comes with AWS. And there is a session on this that Ravi is going to give later today. So if you want to see how this works, please attend that session in the, I believe, the operator track. OK, recap. What does CNC do? It accelerates time to market. It improves your service delivery. It improves your end user experience. It boosts operational agility. And we have some metrics for faster time to service, improved efficiency, and better OpEx utilization, which ties back to what we were talking about with service provider economics changing. So if you want to find out more, you can request a trial. It's cisco.com/go/crosswork, or you can find me or one of the Crosswork team members, and we'll let you know what to do. Right here, Merv, can we display the slide, please? So we also have a session on the 11th, and I want to hear from you. What do you want to see in CNC over the next few releases? And I'm going to talk about the roadmap for CNC based on these responses on May 11th at, I think it's here in this stage. So that's all I have. Do we have questions? OK.
They all kind of relate to multi-vendor, so we can go through them real quickly. So for real-time network visualization, does it support multi-vendor devices for SRv6?
For SRv6, yes, we're seeing a lot of tests for SRv6. There's actually an interoperability report with ENTC. It's on the ENTC official website for 2023, 2020. I want to say 2021. 2022 was, I think, a pandemic thing. And then 2019 also, so check those out. We do SRv6 testing, we do SR testing, I think we do RSVP testing also, we do provisioning, all of the use cases that we talked about, and we do interoperability testing. So it depends on exactly what you want to do with SRv6 with these multi-vendor devices, but we have all of that information up there if you want to check it out.
Okay, kind of a follow-up. For multi-vendor SR, is there one SR domain per vendor, or can you support multiple vendors in a single domain?
We've seen both. We've seen multiple vendors in a single domain also. I think in some of the far eastern regions, we've seen different domains for different vendor networks. It works with both. For CNC, it doesn't really matter.
Cool. Last question, for the use cases you went over, all multi-vendor support? Are there any of those that are specific only to Cisco?
No, they all, there's varying levels of multi-vendor support. There could be a little more customization involved or a little less customization involved, depending on how far along the technology actually is. Okay. So for example, SR is a little more advanced, RSVP even more. And for SRv6, a lot of vendors are still catching up, so it depends on what exactly you're looking for. But mostly, multi-vendor is a core principle for us, so if the answer is not 100% yes, it will be at some point.
Cool. That is it.
All right. Thank you, Omar. Thank you, everyone.